Designing and implementing security. This nugget is all about database security, how to properly design access to our objects while keeping them flexible, manageable, and obviously secure. We'll kick this nugget off by looking at the many security objects at the database level. This is just a foundational whiteboard to make sure we have an understanding of principals, securables, permissions, roles, schemas, all of those database level objects. Then we will look at object ownership and ownership chaining and context switching. All of this stuff is really around ownership chaining, and it's one of those things that's really a double-edged sword. It can really help you when it comes to your security design, or it can really be the source of frustration and confusion. So as long as we keep ownership chaining in mind when we design our security strategy and have an understanding of it, then you'll be in good shape. From there, we'll get some tips on designing security, some guidelines, and also just get a visual on how all of this stuff works together. Then finally, we will jump into the virtual Nugget Lab. We'll take an ownership chaining demo, and then we'll take a demo on how to properly design security with all of these pieces involved. All right, let's go design and implement database security. Let's start at the core of everything when it comes to security, and that is principals. Principals are the objects that request resources. So in the world of Windows, we have user and group accounts, and within there, there's even local and domain user and group accounts. We have, at the SQL Server level, the instance level, login and server role principals, and at the database level, we have user, database, and application role principals. So these are all the objects that can request resources. Securables are those objects that require authorization. So they're access controlled resources. And in SQL Server, we have server level securables. And this is a hierarchy, by the way. But we have server level, and this is just not a complete list by any means, but we have login, server role, database. At the database level, we have user, database and application roles, schemas. And then at the schema level, we have all the things we're really going to be concerned with here: tables, views, stored procedures, and functions, just to name a few. Now, how do we allow principals to access securables? Well, that's all done via permissions. Permissions determine the actions that principals can perform on securables. So we're going to authorize our users. Authorize just simply means grant, revoke, or deny. Grant means give access. Revoke means take access that was previously given away. And deny means completely deny them access to an object. So we're going to authorize our principals to perform these actions in our securables. Those actions are going to be, in the DML world, select, insert, update, delete. In the DDL world, create, alter, and drop. So here's what the syntax looks like for granting permission, and here is an example on how to do so. Another important security object here is roles. Roles just allow us to group principals together, because if you have thousands of users, you're not going to want to manage those users at the individual level. You're going to want to group them together by department or job function responsibility, so it'll make security that much easier. One more important security object here is schemas. So schemas are a lot like roles. Roles are there to group up our principals to make managing security at the user level that much easier. Schemas are there to group up our low-level database objects: tables, views, stored procedures, functions. That way, we can manage permissions against these objects, again, at a high level. So these are going to be the main security objects that we're going to be working with when it comes time to implement security. Let's switch gears a little bit and talk about object ownership and ownership chaining. A couple of important concepts we need to think about when designing our security strategy. Let's start with object ownership. And the three things to remember about object ownership is that the principal that created the object is the owner, and that objects can have only one owner, and owners control access to their objects. Why is that important? Well, it all comes down to ownership chaining. Ownership chaining is one of those things that, if done right, can really save a lot on managing permissions. And let me just go through the definition, and then I'll give you a visual on how this works. So ownership chaining is basically saying that if I have access to an object, and that object references another object, so say I created a stored procedure, that stored procedure selects from a table. Well, permissions are going to be bypassed if both of those objects have the same owner, no matter who is executing the stored procedure. So if I give permission for someone to execute my stored procedure, and they don't have permission to that underlying table, as long as I own both the table and the stored procedure, it's going to bypass permissions. So you can see how that'll save a lot on managing permissions, because now if we do give someone access to a stored procedure, we don't have to go to all the underlying objects and give them that granular access. Now, this is best understood with an example. So let me lay this out here. Let's say that I'm Walt, I'm Heisenberg, and I want to create a secret formula stored procedure. This stored procedure underneath references a few views which reference multiple tables. So how this works is if I execute the stored procedure as Walt, the stored procedure is going to go and hit this view. This view, or security I should say, was going to look and say, hey, look, the owners are the same. So it's not even going to check permissions at all. It's just going to totally bypass permissions. Same thing with these two tables because, once again, the owner is Walt. So as long as the owner is the same, the chain is known to be unbroken and permissions will be bypassed. Now, on the other side of this, while this stored procedure is all cool up top, it goes down to the bottom and says, hey, wait a minute, owners are different, so it's going to check permissions. And as long as Walt has permission to Jesse's view, he's going to be good to go. And then the same thing with Saul's table back here. As long as he has permission, this whole thing will fly. But the whole thing here is that the ownership chain is broken down here, so permissions will be checked. Let's say Walt gives Jesse execute permissions on this stored procedure. Guess what? The same exact thing is going to happen. Permissions will first be checked to see that he has execute permission on the stored procedure. But once that stored procedure executes, it's going to go to this view and it's going to say, you know what? Owner's the same, bypass permissions. Owner's the same, bypass permission. So what that means is Walt didn't need to explicitly give Jesse permission on his underlying tables. He just needed to give him execute permission on the stored procedure. So while that is totally awesome, because it saves a lot of down and dirty permission management for Walt, he doesn't have to go and explicitly give Jesse permission to all those tables. The downside, the double-edged sword part of this is that because of the whole word right here, bypassed, bypass means bypass. So that means if we explicitly deny Jesse access to Walt.table1, it doesn't matter because he has execute permissions on the stored procedure, which means because these owners are same, permissions are completely bypassed. So that's where it can cause a source of confusion and frustration if you do say, hey, I denied him access. Why is he still getting data out of this table? Well, it's because he can access the stored procedure and ownership chaining is in effect. One more piece of this puzzle is context switching, which gives us a way to impersonate users and switch security context. So when Walt executes a stored procedure, his security token gets passed around to all these underlying objects. Well, let's say that Walt changes his stored procedure to add a truncate table command, which requires elevated privileges, something that Jesse doesn't have. So what Walt can do to ensure Jesse can still run this is inside of this stored procedure do an execute as owner. So when the stored procedure executes, it'll execute as Walt, and everything will execute fine. And I should mention, context switching is a great development tool for testing security. As long as you have impersonate permission on the database, you can switch security context and do your DML and DDL tests all day long. And I'll show you how to do that when we get into the virtual Nugget Lab and run some demonstrations. All right, let's jump into one more slide and talk about security design and get some tips and guidelines for doing so. So a great security design, and one that will really make it easy and simplify the whole process, is to number one, zoom in on database roles, make sure all your users are in roles, and then make sure all your objects are in schemas. That way, when it comes time to do permissions, we only have to focus on user permissions at the database role level and object permissions at the schema level. And get all this stuff out on paper first. Document what roles you need, document what objects belong in what schemas, and that way we can be good engineers and measure twice and cut once. And some great guidelines to follow here are use procedures and views for your object access, just like we're doing here. Use database roles as containers for users, and also application roles. If users are only accessing your database through an application, then create an application role and assign them to that. That way you never have to give them explicit access to our servers. Also, manage user permissions, as we saw at the role level. Group like objects into schemas, and then manage object permissions at the schema level. Another good one here is having distinct schema owners. This is one that you see everywhere out there, where DBO owns everything. And that can really get you into trouble with ownership chaining. So a good implementation here of login list users is creating a login list user and associating it, making it the owner of a schema. So have a different login list. You know, if you're creating a sales schema, make a sales DBO login list user. And a login list user is one that nobody can log in under. It's like creating a proxy user kind of. And that's just a great implementation of how to do that. Then anything you create in that schema is attached to that login list user. Also use execute as to control execution context, as we saw. And then cross database ownership we haven't talked about, but essentially it's ownership chaining across databases. The difference is rather than looking at the database user for ownership, it looks at the login for ownership. And the only real reason you should use cross database ownership chaining is if you have an application that uses many databases. If you're an ISP, then you definitely want to turn this off because think about it. If you have many clients, some of those clients could be competitors, and you don't want them even having the remote possibility of getting into your database. So ISPs will disable cross database ownership right away. Another one here is remember the principle of least privilege. Only give users minimal permissions for what they need to access. All right, let's head into the virtual Nugget Lab. We'll start with ownership chaining. We'll get a good demo going on that so you can see how it works. And then we will go into the Nugget Demo DB and do the same thing to see how to set up and configure security with schemas and database roles in mind. All right, so we're in the virtual Nugget Lab. Let's head down to SQL Server Management Studio, bring it to the forefront here. And I added a new project called o3.security. We have a couple of scripts we're going to work with here. The first one we're going to do is ownership chaining. And we're going to take what we saw on the whiteboard with Walt and Jesse and try to recreate that here just so we can see at a base level how this works with users. And then we'll take it to the next step and do it with schemas and database roles and all that in our security design script. So we're going to use loginless users. The first thing we're going to do is create two loginless users, one called Walt, one called Jesse. So let's do that here. I'm going to highlight everything so we can switch to our Nugget Demo DB as well. All right, that looks good. Now if we head over to security, users, we refresh it, we should see Walt and Jesse as a couple of loginless users in here. The next thing we're going to do is create a table. We're going to create a table called periodic table, some columns in it, we'll put some data into it, and then we're going to alter the authorization on it to Walt. This changes the owner. So the end result here is we're creating this table, but we're logged in as SQL Nugget Lab /administrator here. In fact, we can just do this. Select S user underscore S name here. And you can see we are SQL Nugget Lab administrator. So let's create this table. All right, good. And let's put some data into it. Good. And now let's change the owner to Walt. All right, so now Walt is the owner of our table. Now let's see if Walt can get data out of this table. And this is what I mean by great for development purposes. We can switch the security context here of our current connection to Walt by doing execute as user and then the name of our user. All right, so let's do that. All right, now we're Walt. And if we select everything from the periodic table, look at that, we get data out of it. Cool. Now we can revert here, which will switch us back to SQL Nugget Lab /administrator. Now let's try the same thing as Jesse. Let's execute as user, switch our security context to Jesse, try to get data out of that table, and then we'll revert back to our Nugget Lab user. And look at that. We can't do it because Jesse doesn't have access to that table. Now, let's say that we wanted to give Jesse access to the data in that table, but being good designers, we do not want to give him direct access to the table. So we're going to do this by creating a stored procedure. So let's create a stored procedure called getSecretFormula that'll just get some data out of that periodic table we created. And then we're going to switch the owner from us, SQL Nugget Lab administrator, to Walt. So Walt will own this procedure. All right, good to go. Now, before we do anything else, let's try to execute this as Jesse. We know that this is going to fail. And it does because we do not have execute permission on that object. Walt does, so Walt could execute it because he's the owner. But let's do this. Let's execute as user Walt, and let's, as Walt, grant execute permissions to Jesse on that stored procedure. Excellent. All right, so we're Walt. We reverted back. We gave Jesse access. Now let's switch to Jesse, execute the stored procedure, and then revert back, and it works. See that? It works. And we didn't have to give Jesse explicit permission to that table. He doesn't have permission to that table at all right now. In fact, if we head back up here and try to get data out of that table, we'll get the same result. Select permission tonight. So that's good design right there because we're flowing everything through our stored procedures. But on top of that, Walt can give people access to his stored procedures without also giving them access to the underlying table. Here's another one. Here's ownership chaining at work. Let's specifically deny select access to the periodic table here to Jesse. All right, done. But let's go back to Jesse here and execute the stored procedure. Hey, look at that. It works. See that? So even though we said Jesse has no access to that table whatsoever, he can still get to it through that stored procedure. Now, here's another one. Let's say that we wanted to give Walt access to our stored procedure against all of our Nugget Demo DB tables. Well, what we can do, we're back as SQL Nugget Lab /administrator here. Let's grant execute to Walt on that stored procedure. All right, good. And now let's execute as Walt that stored procedure. Done. And notice we didn't give Walt any permission. Walt cannot do anything against these tables. The only way Walt can get at that data is through this stored procedure. And by the way, permissions weren't checked after Walt hit that stored procedure because we created everything here as DBO, and this stored procedure is also DBO here if we look. So it only checked Walt's permissions against the stored procedure, then everything else was bypassed, which is why he could access the data inside of those tables. So that's ownership chaining to a T. let's look at let's really just take this to the next level and see how we can incorporate schemas and database roles along with ownership chaining to make this all work. So what we're going to do here is we're going to create first a login called SQL Nugget Lab /HR. HR is actually a group. In fact, here, let me show you this while we're here. Let me head over to administrative tools in the start menu up to computer management. And if we go into local users and groups, I created a user called HR user 1 and a group called HR. All right, so we're good there. Now we're going to create a login, a SQL Server level login associated with that Windows account. So let's do that. Execute. All right, good to go. Now we need to switch databases. Let's switch here to Nugget Demo DB. And now we're going to create a user in this database called the same thing, SQL Nugget Lab HR, for that login that we just created, the instance level login. So we're going to have a database login here in Nugget Demo DB associated with that instance level login. Let's do that. Very good. And now this is where a more good design with schemas comes into play, because we're going to create a loginless user called HR DBO. And this is where we're going to create the schema underneath this HR DBO loginless user. So let's do that. We'll create our loginless user, get set up for creating our schemas and associating our owner with it. Then we're going to create a database role called HR that's also going to be owned by our HR DBO. All right, so that looks good. And I'll show you what all this looks like in Object Explorer here in a second. Then we're going to alter our role here, HR, that we just created, and add that member into it. All right, good. And finally here, let's create this schema, HR, and make the owner, again, HR DBO. All right, so let's see what we did. Let's take a breath here, take a step back, and see exactly what that did. So let's go first here into security. We'll scroll down, and we should have our user in here. There it is, SQL Nugget Lab HR. If we head down to roles and we look at our database roles and refresh this, we should have our HR role. There it is. And then if we head down to schemas here and refresh, we should also have an HR schema. Good to go. One more thing that we should do here is make the default schema for this user our HR schema. All right, so we'll do that. There we go. So now we have a default schema associated with that HR user. And now the next thing we need to do, and this is where we're going to give some permissions here using both database roles and the schema. In order for users to be able to create tables in a schema, we need to give them create table permissions. So we're going to do that first. All right, that'll give them create table permissions in the database, and then we can grant alter on the schema HR to SQL Lab HR. So this is what you'll need to do if you want to allow users or roles to create tables within a schema. So right now, this user, SQL Nugget Lab HR, will only be able to create objects, create tables in this case, inside of the HR schema. And let's see if all that worked. We're going to switch our execution context here to our HR user 1, which belongs inside of that Windows group, which is associated with that database role. And then we'll create two tables, one called employee, one called department, and then we'll just print out here just to show that it was all executed under this user's context. So if we do this, there it was. Okay, it was executed as this. We can head up to tables. We can right-click, choose refresh, and look at that. Now we have two tables underneath the HR schema. So now, since we own these and we can sit here and do all our development and build reports and as an HR user do whatever we need to do against our tables, but let's say that marketing has a need to work with some of the data in the employee or the department table. We could create a stored procedure that only gives them, or even a view that only gives them the data that they need access to, grant marketing permission to that stored procedure, and now they can access the data in these tables without, again, explicitly needing access to the tables themselves. And on the flip side, let's say that these core tables, we only want developers or true DBOs, true administrators to access our core tables, but we still may need to give many departments access to the data within these tables, just not the schema, right? Again, we don't want anything accessing these things directly. So same thing, let's say we wanted to give them access to our get core stats stored procedure. And right now, we're still logged in as SQL Nugget Lab HR user. If we execute this, we do not have select permissions or execute permissions against the table or the stored procedure. So here's where we could revert back to SQL Nugget Lab. So now we're back as the DBO. We could grant execute on our stored procedure to our HR database role. And now if we execute as that user, we should still be able to execute the stored procedure, but they will not have direct access to the table. And as you can see here, we get the results from the stored procedure, 219 rows affected, but the second statement failed because they do not have select permission against the course. So this is good design. It's good design simply because we're not dealing with permissions at that object level. We're dealing with it at the container level. And one neat thing I want to show you, and let's face it, coming up with what users belong and what roles and what objects belong and what schemas, that's pretty straightforward. That's pretty much already defined for us. It's just a matter of understanding our database, our company, and our applications. The tricky part is always going to be permissions. And if you're the type like me that loves to just plaster your walls with big diagrams so people, when they come into your office or whatever, think you're a total stud, this is for you. And I'll give you the URL for this. But this is awesome because it holds all the permissions in SQL Server. So let me zoom in here a little bit. So here we go. Here's some database. Here's all the database level permissions. So it shows not only the permission hierarchy across servers and databases and roles and all that, but it also shows you the statement that you can use. So this is just an awesome reference for dealing with permission. It also shows you how to read this. Here's some syntax to live by, pretty much what we looked at in our whiteboard, how to read the chart. But it's just a great reference for all things permissions. In the CBT Nugget, we learned how to design and implement security. We started off by getting familiar with the physical security objects we'll be working with at the database level, specifically principals, securables, permissions, roles, and schemas. We then got familiar with object ownership and ownership chaining. We saw that ownership chaining can be a really good thing, but it can also be a bad thing if we're not careful when we design our strategy. We then got familiar with the security design, a very basic one, something that will really make managing permissions easy, and that is putting all of our users into our database role containers and then putting all our objects into our schema containers and managing permissions at the schema and database role level. We also got some guidelines, and at the end here, we jumped into the virtual Nugget Lab. We saw ownership chaining at a very basic level, just at the user level, and then we took it to the next level where we designed security. We saw ownership chaining, schemas, database roles, and database objects all working together. I hope this has been informative for you, and I'd like to thank you for viewing.